Hello all, welcome to Soumya's Tech Talks. Today in Smart Pointer series, we will discuss on weak pointer. We will see what is the weak pointer and what is its usage, and also we see some of the examples. Let's start. So the topics we cover today, the weak point introductions and its use cases, and also some example programs. So the weak pointer is it will be used along with shared pointer. So it generally creates the weak reference. Like if a shared pointer is managing a object on the heap, so if you create another shared pointer, that is a strong reference. Like strong reference means reference count will increase. So if you don't want the reference count, strong reference count to increase, then you can use the weak pointer. So creating weak pointer, it does not increase the strong reference count. Okay, it generally used for the circular references. Like we will see after some time what is circular reference, and also we will see how this will be solved using the weak pointer. So generally you can see here there is a example of circular reference. Let's say I have two structures, so each is having shared pointer reference to other one. Like a is having shared pointer object for b is having shared pointer object of a. So when we create, so here I have created the shade pointers, and here I am assigning a shade pointer to b shade pointer to a. You can see here. So this is called circular reference. So once your main program exit, or if you see this, let's say if it is not main, some other function, if it exit, what happens? The shade pointer destructor should delete this integer, uh, delete this object, these structure objects. So as the shared pointer goes out of scope. But here the problem is both are having a shared pointer of others. So it is called circular reference. Due to circular reference, even though the shared points are out of scope, so they mutually refer to each other. So nothing will be deleted. Both objects will be in the heap, which leads to the memory leak. So to avoid this, we can use the weak pointer. We'll see how to do that. So weak pointer, even though you have the weak pointer, you cannot directly access it. You cannot use it to access the object on the heap, which is being managed by shared pointer. You cannot access directly. First, you need to acquire a shared pointer from the weak pointer using the lock API of the weak pointer. So here you can see this program. I have a shared pointer. I created a weak pointer from that. So this is the syntax. So weak pointer equals to shared pointer. Here what happens? So it won't increment the strong reference count, but it will increment the weak reference count because there is a weak pointer created. So, but the problem is I cannot use this directly. So if you want to access this integer managed by the shared pointer, you cannot use it directly. So how you can use? So you have to acquire the shared pointer from the weak pointer using this lock API. So you will get a new shared pointer, but once it comes, you have to check whether it is null or not, because most of the times, so there may be a chance that the object being managed is already deleted. So in that case, you don't get the shared pointer object. You instead you will get the null pointer. So you have to check. So if you access directly, you will lead to a crash. Okay. So after once you acquired, you can access it. You can print and you can modify it like this. Okay, so here the s- count will increase. The strong reference count will increase to 2 because you have already SP is one shared pointer, and this acquired shared pointer is one more. So the count is 2. So once this is the block, so this is the code block, right? There is a scope in this. Whatever variables created here, so the scope is bind to here. Once this block exit, so they will the variables, local variables of this block will be out of scope. So here the acquired shared pointer will be out of scope after this brace. So the shared pointer acquired here, acquired SP will goes out of scope and it will be destroyed. After this, you have a you have one strong count and one weak reference count. Okay. So how the usage, if you see the usage, first we have to initialize the weak pointer from the shared pointer. You have to create a weak pointer from shared pointer like this. So the syntax is weak pointer, the template is of same type, and here B, you are assigning B is the shared pointer. Here, so normally when you assign shared pointer to another shared pointer, the strong reference count will increase. But here the strong reference count won't increase, the weak reference count will increase. So next step is how to use it. So you have to acquire shared pointer from the weak pointer using the lock API. Here the strong reference count also increase. It will 2 and weak reference count is 1. So you have to check the acquired shared pointer from the weak pointer is null. If it is null, not null, you can continue. If it is not null, if it is null means the object being managed by the shared pointer is already deleted, so you should not access it. uh, you have to exit. So once you acquire it, you can do anything you can do on the object acquired, shared pointer object acquired. So once the shared pointer acquired is out of scope, it will be reduced, it will be destroyed, and the strong reference count will be reduced for here. So here it will be 1, but weak pointer, as you created a weak pointer, weak link. So until the weak pointer is destroyed, the weak reference will be 1. So here is the RAM. Normally the shared pointer will have a pointer and the control block. So the control block, you can see the how the shared pointer object is created on heap. So it will have a control block. So in earlier lectures, we define what is the control block, what are the information available inside this, and all the things. How the control block will be created when the shared pointer constructor calls. We discussed this in the previous lectures. You can refer. So this is the object being managed. So you have a pointer to it and you have a control block. If you comes to control block, again it will have a pointer to the managed object, and it have a variable called strong count and weak count, and the custom deleter which will be called whenever the shared pointer is destroyed. The custom deleter function will be called, which take care the cleanup job. Earlier we have already discussed. So this is the object being managed by the shared point. So whenever the shared pointer destructor calls, once shared pointer goes out of scope or it is reset by the program, then the destructor will be called. So first it will decrement the strong reference count and it will see whether the strong reference count is 0 or not. If strong reference count is 0, it will delete the managed object being managed, and after that it will check the weak reference count. If weak reference count also 0, it will also delete the control block. So everything will be cleaned and the shared pointer is no more useful here. But here the object is deleted, but the control block still exists, so that whoever holding the weak references, so they will know that okay, they have to know that the shared, if you remove the control block here, so if some other program thread or somewhere, if it is holding the weak pointer, then they will crash. They want to get the try to get the shared pointer, they will crash. So it won't delete the control block. So whenever the weak reference count is 0, then the control block will be deleted. So thanks for watching. Please share this video to all your friends and colleagues. We will continue on the lectures on C++ programming. Bye for now.